Can you see this slide? Weed seed dispersal.
Yes.
Hello?
Hello. Yes.
Yeah, okay. We will just have to go through with the dispersal. Uh, when weeds produce seeds, they have to be dispersed. They don't stay around the plant, they have to be distributed. So, weed dispersal is the movement of weed seeds, movement of weed seeds from the source of production to other areas. It's seed movement and the dispersal mechanisms which are important to note. Now, the causes of seed movement are abiotic, biotic, and agronomic. Abiotic consists of the action of wind and rainfall. Now, there's certain terminology which we use. When we refer to wind dispersal, we talk of anemochory. Dispersal due to rainfall, it's known as hydrochory. Now, let us look at the biotic causes uh, or the dispersal due to biotic causes. The term which we use is zoochory. That is the term which we use. So, organisms are capable of dispersing seeds by adhesion. That process we call it epizoochory, where you get seeds attached to animal skin and then they are dispersed. Now, if the seeds have to be eaten and pass through the animal duct without being damaged, that is endozoochory. We have, to a small extent, dispersal carried out by ants, mime cocori. Then there is a dispersal which is caused by splitting of the fruit, which is known as autochory or ballistic dispersal. We also have these terms barochory and pseudoserotin, which I will explain later, which may not be, this dispersal may not have special mechanisms. Anthropochory is the dispersal which involves humans as fundamental drivers of dispersal. Right, we are now going to start on horizontal seed dispersal mechanisms. Now, this is mainly due to wind, what we call,
Job.
yes.
Someone wants to join.
Now,
Lecture.
yeah, it's no longer possible because the system will not allow it. So let us finish. Then she will join. He or she will join in the next lecture.
Okay.
Yeah. Okay. Let us proceed. So I said this anemochory depends on wind speed. Most of the weed seeds in Zimbabwe are likely to be dispersed by the wind during the dry season. Now, this is a result of wind-driven aerial movement. Weed seeds resemble parachutes. For example, conizer species, we have wings or plumes which that aid flight. So this is the conizer arubida. It has these fluffy seed heads. Sorry. Okay, sorry about it. Okay, let's proceed. So conizer arubida has got seeds with fluffy structures. This looks like a cotton, but it allows the seeds to float in air. Agemone mexicana also has these fluffy seed heads, which can easily be carried by the wind. Milenis repens has also seeds which can easily be carried by the wind. Let us look at hydrochory. Seeds are transported by water runoff or by floating along water drainage channels. This form of dispersal is likely to be common during rainfall season in Zimbabwe. Weed seeds capable of floating in water are transported to other areas. Raindrop action can also disperse some weed seeds. Epizochory, this is where we have seeds being attached to animal fur or seed adhesion to animal fur. So animals are involved in this kind of dispersal. We have cattle, horses, donkeys, sheep, and goats. Also wild animals. Now, the seeds have special characteristics which make them attached to animal skin. Examples of weed seeds which can attach to the animals are Xanthium strumarium, Bidens pilosa, Tribulus terrestris, Acanthospermum hispidum. This then is Xanthium strumarium seed. Please notice these hooks. It can get attached to animal skin. Tribulus terrestris seed, it has also these hooks, which allows it to get attached to the animal skin. This is Biden's pilosa. It has got seed heads with hooks, so it can easily get attached to animal skin or even to human clothes. This is Acanthospermum hispidum seeds. Notice these hooks, and these hooks enables the seeds to get attached to animal skin. This is a grass known as Setaria verticillata. known as Setaria verticillata. Now, the seeded is some seeds which can stick to animal skin or it can stick to clothes. And that's how it is dispersed. Then endozochory involves the ingestion of the seed by the animals. Birds are also involved with this type of seed dispersal. According to Thomas, 1970, guinea and cattle could disperse Rhodboria coccinkinensis seed. Rupende in 1997 reported that Elusini indica was associated with the manure application. So cattle aid the dispersal of Elusini indica. Now, Maime kokori is the dispersal of weed seeds by ants. Small distances are involved, just about 2 to 5 meters. We have Datura stramonium seeds, which are known to be dispersed by the ants, according to Ben Venuti in 2007. Now, Datura stramonium seeds produce a lysam, which is a chemical which attracts ants. This enables the seeds to be dispersed by the movement of the ants. Then we talk of ballistic or tokory. This refers to explosive dehiscence or a splitting of a fruit with a forceful ejection of seeds. Here, short distances are involved around the mother plant. We have got again Datura stramonium. It is a fruit which can split and scatter seeds around it. Creomonophila has got also a fruit which can split and scatter seeds around it. Now we talk of barochory. This is not a true dispersal mechanism. There is absence of any device for moving the seed away from the mother plant. The seeds remain inside an open calyx in the apical zone. This may actually protect the seeds or may prevent seed predation. Examples are Canopodium album and Amaranthus retroflexus. So this is Canopodium album. Pseudoserotin, again, more or less a similar situation where you have the phenomenon of seed retention in closed, usually woody fruits or cones. Seeds are protected from predation. Here we don't have we don't have weeds for this example actually. Now, anthropochory could be the major dispersal mechanism where human activities are involved. So, seed dispersal is caused by human activities. We have agronomic activities such as working implements, seed adhesion to the tires of the operating machines, combine harvesters used on several farms could aid seed dispersal. Application of manure could spread weeds such as Leucine indica, Amaranthus hybridus, as was reported by Rupende in 1997. Striga seed can contaminate crop seed. So if farmers, sorry, hello, yeah, yeah, just wait till I finish. You are going to join in after this session, otherwise the system will be disrupted. So hang on a bit. Okay. Yeah, hang on a bit. You will come in. Okay. Okay. Thank you. All right. Sorry for this disturbance. I was about to talk about striga seed contamination. Now, farmers may share seed like sorghum and peru millet, and this seed could be contaminated by striga seeds. So during seed trade, some of the weed seeds can actually uh, be dispersed. For example, the presence of Chenopodium album in Zimbabwe was due to the wheat seed movement from Europe. When farmers in this country were now using that seed, Chenopodium album was introduced. Now we're going to focus on the seed movement within the soil. This is very, it's not a big, it doesn't, it doesn't give a big influence to seed dispersal. Okay, we may have seed barrier depth, uh, which is linked to germination. It affects buried seed availability that is mediated by phytochrome in photosensitive species. So if we bury weed seeds, they may fail to germinate because of phytochrome control. Another issue could be the gas exchange, which can be limiting. So absence of oxygen may actually reduce the germination. What we are referring as hypoxia and inadequate gas exchange can actually inhibit germination. Soil tillage operations influence the distribution of weed seeds within the soil profile. Tillage can move seeds up and down the soil profile. In minimum tillage systems, the weed seeds are concentrated near the soil surface. However, conventional tillage could result in uniform mixing of seeds within the soil profile. On heavy soils, please note that there could be soil cracks, which may facilitate the movement of weed seeds down the soil profile. Now, some weed seeds can penetrate into the soil using awns as they acquire moisture. They tend to stretch. During the stretching, when they stretch, they actually force the seed to go into the ground. This stretching action by the awns is common in wild oats, and it can facilitate cell of burial, but it's a small movement. Burial also accounts for weed seed longevity and dormancy. Activity of earthworms can bring buried weed seeds to the soil surface. A similar weed seed movement has been attributed to beetles, similar to what earthworms do in moving seeds. Ants also act as agents of weed seed vertical movement. So here we are just talking of weed seed dispersal within the soil, which is very limited. If you want to get full information on what I have been discussing, you may have to look at this reference by Ben Venuti in 2007. It can give you an in-depth it can give you in-depth information about weed seed dispersal. So I'm going to end here so that we can admit others. So let me stop.